Don't forget to subscribe and ring that bell.
How we doing? Welcome or welcome back as we continue down these 2022 practice questions for AP Calculus AB. We're going to do free response question number 4. And guess what? No calculator. It's okay. We got this. Beautiful day, beautiful content in calculus. Let's get started, shall we? Right off the bat, I love question number 4 because when I see that table, I know at some point they're probably going to ask me to do an LRAM, an RRAM, a trapezoidal rule. I love it. Let's see if we're right here. Number 4 says, an ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. The radius of the base of the cone is given by twice differentiable function r, where r of t is measured in centimeters and t is measured in days. The above table, or the table above, gives selected values of r prime of t, the rate of change of the radius over the time interval from 0 to 12 inclusive. 4a asks us to approximate r double prime at 8.5. using the average rate of change of r prime over the interval from 7 to 10, inclusive. Show the computations that lead to your answer and indicate the units of measure. I tell you what, they didn't even have to give you any of this information right here. All of this, that is pointless. The moment they tell us to approximate the second derivative of r at 8.5. That means, okay, 8.5 would be here in the table. Since we can't take the derivative of the equation of r prime to get r double prime, remember, in order to get that, I got to take the derivative with respect to t of the first. We can't do that. We don't have an equation. We can only approximate it. That's why it tells us approximate. I'm going to use my change in y over change in x for the two closest points from 0 to 10. I mean, they give you that here, and that's fine. I mean, they basically tell you what to do. But you are to the point where you should know when you approximate a slope at a point from a table that's not on the table, you grab the closest point. You sandwich that value. I'm sandwiching 8.5 with 7 and 10, the two closest. And I just do change in y over change in x. So let's say, we'll call this y. Okay, I thought I hit the red one. There you go. We'll call this y2, y1, x2, x1. And I'm just going to do y2 minus y1 over x2 minus x1. What's that, 8th grade math? Come on now. So I'm just going to do negative 3.8 minus negative 4.4 all over 10 minus 7. Okay, and we don't have a calculator, but don't freak out. Okay, when I subtract a negative, this is going to turn to a positive. I'm like adding these, and I should get 0.6 over 3, which gives me 0.2. And it says indicate units of measure. It is not centimeters per day, but it's technically, if this is the first derivative, it's the second derivative. So if it's the second derivative, I'm going to put a little 2 right there. Centimeters per day squared. And that's it. I mean, that was easy. The explanation for this problem took so much longer. 4b. Is there a time, t, between 0 and 3 inclusive, for which r prime of t equals negative 6? Justify your answer. Another piece of cake right here, okay, between 0 and 3. So in this little interval here, they're saying, will I have a negative 6 somewhere, value, somewhere here at the bottom? We should. And I believe we're going to use the intermediate value theorem. What do I mean? The very first thing you need to recognize is that if this is a differentiable function, okay, if it's twice differentiable, that means r prime and, I'll do that, r double prime are both differentiable. And if something is differentiable, it has to be continuous. Okay? So let's take a look at this. I mean, I'll give you the visual for the sake of explaining. Although I don't think, I mean, if you know what you're doing, the visual isn't necessary for you. And you don't need the visual when you're answering the question. But if I were to graph this information I have up here, okay? I guess I have to go down here. At 0, I'm at negative 6.1. So at 0, I don't know, right here, we'll call that negative 6.1. Big dot. And at 3, you'll notice I'm at negative 5. So let's go here. We'll go here. It's 3. We'll go here. I don't know, negative 5. Again, if this is continuous, I got to draw a line that gets from here to here. It doesn't matter how I draw it. In green, maybe it comes down like this, up like this. Maybe I'll do this in blue. Maybe it goes glah, 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 glah. It doesn't matter how I draw it. You see negative 6, which I'm going to do here in purple. Any one of those lines I drew, that, has to touch negative 6 once. The blue one touches it here. The black one touches it here. And the green one touches it here. If it is continuous, and we know it's continuous because it's differentiable. In order to get from negative 6.1 to get all the way to negative 5, I have to pass negative 6. You have to. You have to. I cannot count from negative 5 to negative 6.1 without going through negative 6. Okay, and that's the whole premise of the intermediate value theorem. Okay, so is there a time? It doesn't ask me to, state the time. It says, is there a time? Yes. I'm so excited, I'm going to use an exclamation point. And I'm going to say, since r prime of t is differentiable, it must be continuous. Okay? That's important. All right? Comma, by my intermediate value theorem, okay, r prime of t, okay, has to be negative 6 at least once, maybe more than once, but at least once to go from negative 6.1 up to negative 5. Oop. I mean, and that's you could write it 500 different ways, and all 500 could be correct. Well, you can write it 1,000 ways, it would be wrong, but as long as you get that general information, r of t is continuous, okay? R of t is continuous. By the intermediate value, wow, what the heck is that? By the intermediate value theorem, it has to be negative 6 because it goes through negative 6.1 to negative 5. You got to hit it once. Got to. And here we go. 4C. When we started this, I said they've got to ask us at some point to do an RRAM, an LRAM, an MRAM, or a trapezoid rule. And here it is with 4C. Using a right Riemann sum, which we should lovingly know as RRAM, with 4 subintervals indicated in the table, okay, use that to approximate the value of the area under the curve, or the integral from 0 to 12 of r prime of t dt. All right, let's get started. We have 0 to 3. Okay, that has a width of 3. Then we have from 3 to 7. Okay, here's an issue. The width is not the same. This is a width of 4. Let's continue. We've got 7 to 10, which is also different from the previous one. 3. And then we have 10 to 12, which is different than any other one, because that is 2. So I'm going to handle, because the widths are not the same, I'm going to handle all of these rectangles that I drew in different colors like their own individual MRAM, or in this case, RRAM. If I'm looking at my blue values, I use the right one, which is -5, and I multiply that times the width, which is 3. I'm going to add that to the RRAM process for just the red triangle. Okay, I have two values here. I'm using the right one. It's -4.4. Going to multiply that times the width of 4. Don't freak out. These are simple calculations because we don't get the calculator. So look at the green. I have 2. I want the right one, which is -3.8. And I multiply that times my width, which is 3. And lastly, we need to do the purple one and add that. Okay, I have two values here. I want the right one, -3.5. And I'm going to multiply that times 2. All right, well, let's just do our math. Okay, this purple one, 2 times -3.5 is -7. Okay. The green one here would be 3 times that. That's 24. Carry the 2. It's -11.4. All right. And let's go on to the next one. On to the next one. Oh, okay. The red one here. Oh, that's 16. It's 17.6 negative. All right. And we're going to add that to our blue one here, which would just be -15. All right. So if I don't have a calculator, I like to do this, you know, it's a series. You can do it any way you want. I got 10, 20, 30. Okay, then I have 5 and 7 is 12, plus 1. Okay, 12, that's 13, plus 7, that's 20. So I got another 20. These are negative. Okay, and then I have 0.6 and 0.4, which is 1. Negative. Wow, did that come out to be a nice even number? It does. -51. You could have done that several different ways. But that's very doable. You should get -51. Easy. A was easy because it was 8th grade math. Okay. B was easy because you're just explaining why it should be -6, continuity. And C was easy because you're just multiplying and adding simple numbers. All right, since A, B, and C were easy, now we're getting one that has a little bit of substance to it. And this is good. I like it. D, the height of the cone decreases at a rate of 2 centimeters per day. Okay, so what I'm going to do is I'm going to go height decreases. So this isn't H. It's the change in rate of H. I'm just going to call it H prime. And it decreases at 2, so I'm going to say it's -2. Decreases at 2. Okay, at time equals 3 days, the radius is 100 centimeters, and the height is 50. So these are actual values. My radius is 100. These are not rates. These are actual values. And my height is 50. Okay, that's at time equals 3. At time equals 3. Okay. And we have this one here. Find the rate of change of the volume of the cone. Okay? So we're going to do the rate of change of the volume of the cone with respect to time. Okay, at time equals 3. So I need to find the change in volume. So I'm finding V prime. That's what I'm finding. Where? When time is 3. The volume of a cone, thank you for giving that to us. Although we should know that, it's almost a basic one. Is volume equals 1/3 pi r squared h. What we are going to have to do, the first thing we're going to have to do here, is we're going to have to find V prime from this. We're going to take the derivative of this. Okay, so V prime equals 1/3 is a constant, so I'm just going to leave it there. Pi is a constant as well. I've got to do the power rule, or excuse me, the product rule right here. It is first. Okay, it is the first, r squared, times the derivative of the second. The derivative of h is 1, but it's 1h prime. This is a related rates problem. Anytime I take the derivative of a variable, I got to write that variable with the little prime symbol next to it. Or in this case, you can write like dh dt if you really want to. So it's first times the derivative of the second, plus the second, just as it is, it's h, times the derivative of the first. The derivative of r squared is 2r, but I also got to write r prime next to it, okay? There we go. Now, I think we can really just, I think we have everything we need. Let's take a look at what we got here, all right? Let's take a look at what we got. This 1/3 pi will just stay there, okay? R, the radius is 100 at time 3, so that's 100 squared times h prime. That's -2. Plus h, well, my h is 50, that's given to us, times 2 times my radius, which again, it's 100, times r prime. What is r prime, okay, at 3? It's not given to me anywhere in this problem. Isn't this table the table of r prime? It is. At time 3, r prime is -5. So r prime of 3 at time 3 is -5. So that's what I'm going to put in for r prime. Oh, I love when they give us all that stuff. That stuff is good stuff. All right. Let's do this math and get the heck out of here. All right, so we still got this 1/3 pi. I'll just carry along. Okay, then I have, 100 squared, my God, times -2. That's going to give us -200,000. Plus, ooh, we have more negatives. Yeah. Okay, 2 times 100 is 200. Okay, times 50, that's going to be an extra 0. Well, I'll just do the 50 here. It's extra 0 and then 10. Then times -5. If I do that right, that should give me -50,000. Okay. That's -250,000. Yeah, that's 20,000. I don't know why I said 200,000. Let's get rid of one. Oh. I'm like, wow, that was a big number. Make sure we don't go too fast, kids. So -20,000. There you go. There should be 4 zeros. If I'm squaring 2 zeros, there should be 1, 2, 3, 4. There you go. 4 zeros. I thought that was an extraordinarily large number. But I got -70,000 right here times my 1/3 pi. And if I want to, I'm going to say -70,000 pi over 3. There you go. That wasn't bad at all because we were given. Okay, a lot of times we got to use one equation to find like the change in rate in r, and then that's going to get applied to a second equation. But they didn't do that to us here. This was really basic. Everything was given to us. Let me say this one last time. R was given to us in the problem, 100. Okay, H was given to us in the problem, 50. H prime was given to us in the problem, -2. And I want to go to the purple. R prime was given to us in the table. I mean, all we had to do was take the derivative of that. That's really just testing you in the product rule. I hope you get a problem this easy. Okay, 4A was 8th grade math, changing y over changing x. 4B was just explaining that if something's continuous, it's got to go through every number. Okay, 4C, what was that? We're really just multiplying and adding, or in that case, subtracting. Cake. And 4D was the simple one here where everything was fed to you. It was a product rule. God, I hope you get problems like this on your final. Good luck on it. You got this, and I'll see you for question for response number 5.
Don't forget to subscribe and ring that bell.